Find f prime of x given that f of x is x times the quantity 1 minus x squared square rooted. Okay, so first thing I see here is the product rule. So I'm going to write up the product rule, uv prime equals uv prime plus u prime v. You know, you think that I would stick with like either f of x, g of x, or u and v, or u of x. Yeah, my notation is terrible, and I apologize for that. Kind of, sort of. Sometimes I think it's more useful to use u and v as functions, and sometimes it's easier to use f of x. But I can see how someone from the outside look at it and be like, oh, that's terrible. You shouldn't mix those things. Not right. Okay, so I'm going to say that u equals x, the easy one. U prime then just equals 1. V, 1 minus x squared to the 1/2. Square root is just to the 1/2 exponent. And then this is going to be the chain rule. So 1/2 times 1 minus x squared to the negative 1/2 times negative 2x. Where negative 2x is the derivative of the interior. So take the derivative of 1, that's 0. Take the derivative of x squared, that's 2x. Negative, well, that's just the negative. Then we put everything together. Whoop. Whoop. So this will equal, change colors, purple. Ooh, I like purple. So u will be x, v prime will be the 1/2 times 1 over 1 minus x squared square rooted. I'm kind of banking on something simplifying here. Plus u prime, which is 1 over 1 minus x squared square rooted. And then we'll say this is, I guess, over 1. Alright, now to simplify a little bit. I know, another color change. That way I can show that things are canceling. Equals x over 1 minus x squared square rooted plus 1 minus x squared square rooted. I'm going to take a look at the answers over here, see what they have for possibilities. So I'm going to multiply the top and bottom by 1 minus x squared. Let's see what happens. So if we multiply everything by 1 minus x squared, we have x times 1 minus x squared square rooted all over 1 minus x squared plus 1 minus x squared over... Nope. Wait a sec. I'm just going to multiply the right side by 1 minus x squared square rooted. Okay. So I have x over 1 minus x squared square rooted plus 1 minus x squared all over 1 minus x squared square rooted. So what I did is multiplied by 1 minus x squared, 1 minus x squared, square rooted. And the idea here is we get a common denominator. The bottoms will be the same. So now we can combine these fractions. And so then we have negative x squared plus x plus 1 all over 1 minus x squared square rooted. Let's see if that's a possibility. Nope, there's a lot of squares there. I think I missed a square there. Okay, so this will be x squared. So that will change what this is to, let's see here, this will be 1 over 1 minus x squared square rooted. Okay. Oh, and the negative. Gosh darn, I'm missing everything here. Okay. So going back, looking at this, we have, this should be negative x squared. And so we have negative x squared plus, and so we have 1 minus 2x squared. Okay. such silliness, so many unnecessary mistakes, unforced errors, as you would say in baseball. Whoop. So we have 1 minus 2x squared over quantity 1 minus x squared. So it's this one. All right, so let's check this back real quick. So we had the product rule. X on one side, 1 minus x squared square rooted on the other. We use uv prime plus u prime v. We write everything out. We try to minimize our mistakes. And so then we get something that's kind of like this. And we have we're adding two different fractions. I guess one of the fractions is over 1, so is it even really a fraction? I don't know. Everything's a fraction in life. So we want to combine these. And the way we combine it is common denominator. Multiply the top and the bottom by common denominator. And we get 1 minus 2x squared on the top. And then a 1 minus x squared quantity square rooted on the bottom. And then one of the other possibilities, you might be able to look at this too and be like, well, this is a difference of squares. And you might be able to simplify things that way. But this is simple enough. And so the answer then would be this guy right here. So I guess the key takeaway from this problem is don't make simple mistakes. Well, don't make mistakes. Life is simpler when the fewer times you get tripped up. So that's the idea behind this problem. Go team.